What's up, guys? Here I am coming to you live from my isolation booth. I'm actually feeling a little bit like I'm not going to die this evening, so I thought I would go ahead and get you a lesson. Sorry if you guys couldn't open the practice ACT on Monday. Possibly the problem was that I posted the entire test instead of just the math pages, so I'm going to go back and post those math pages. I would like everybody to do it, but definitely my juniors. Okay, you guys, and I'm like I told you, I'm still going to be able to help you guys get ready for that ACT. Anyways, for today's lesson, though, we're going to talk about adding, subtracting rational functions. So if you guys kind of remember back on this, when you did like multiplying, dividing fractions, it's like, oh, I'm chilling, like that's not so hard. And then you get to adding and subtracting, and it's like, ah, frick. Because remember, what you have to do is you got to go like, okay, the 4 and 5, I need to get those both to go into 20. So I got to do times 4 on top and bottom, times 5 on the top and bottom. So I have 8 over 20 plus 15 over 20. And then only once the denominators are the same, right, I have 18, 19, 20, 22, 23 over 20. Okay. You know, it's a super weird symptom that I'm having, and I hope you guys don't notice it too much in this video when they talk about brain fog. You guys, I'm like, I can't even with the brain fog that I'm having, I swear. Sometimes I just can't think of words, or I'll be talking and I'll just completely forget what I'm saying. It took me a hot second to do 8 plus 15, but whatever. We're good. We're chilling. Okay. Now, you know, obviously, if we're trying to get a common denominator for this, and, you know, if you really wanted to, I could be like, okay, I'll multiply this one by 12 and this one by 16. But you guys see that that number would be like way too huge. Like, we're not trying to do that, right? Too much. Okay. So you want to see what they both go into. And if I start thinking about powers, multiples, it's like 12 times 4 is 48, and 16 times 3 is 48, okay? And most of you guys could see that like from the numbers. But let's see what actually happens, like where that kind of comes from. Okay, 12 is 4 times 3. 16 is 4 times 4. So look, they've got a 4 in common, but this one needs a 3 to be accurate and to match up, and this one needs a 4 to match up. Do you guys see that? So the one that they already both have in common, they both have a 4. Like, I don't need to use that, right? I just have to use the other ones to make sure I get a common denominator here. Well, so I end up getting, 36 over 48 minus 15 over 48, which gives me 21, I think. 21 over 48. Now, once you get to this step, you do want to check and see if you could simplify down more, even though, like, you know, from the beginning, well, actually, that 9 over 12 could have simplified down more, but that's all right. Anyways, we could check to see if I could simplify this down. Like, oh, these both divide by 3, right? So it's going to be 7 over 16. Okay? Yeah, so hopefully you guys, that makes sense. Okay, so knowing that, we're going to do the same thing with rational functions. All right? Let's see. The most common is going to be like just two totally separate terms, right? This one is like x minus 2. This one's x plus 4. Okay, so this needs an x minus 2. This needs an x plus 4. And then I go like this. So I have a common denominator. Doesn't really matter which order I write it in. And then on the top, I'm going to distribute that. I'm going to distribute that. And then I'm just going to combine like terms. Okay. 5x plus 3x, that's going to give me 8x. 20 minus 6, that's going to give me 14. Over x minus 2, x plus 4. Okay? Now, The bottom part where it's like factored out right here, you guys, you always leave that factored out. There's almost no time where we would actually multiply that out because that's like not that helpful. Now, you can also try to factor the top to see if it factors or not, okay? Now, this one does, but I can only take out a 2, and then it's actually 4x plus 7 over x minus 2x plus 4, and then that's all that can happen. So you still want to check if it can factor or cross out at the end, right? It's just very hard to make these type of questions like work out like that, so they just usually don't. Okay? Okay, so let's go ahead and look at this next one here. We've got x plus 3, x minus 3, so I'm going to multiply this one by x plus 3. I'm going to multiply this one by x minus 3. Okay. When I distribute this, I get 6x minus 18. When I distribute this, you guys, I want you to do something that will help you make like kind of less mistakes here, okay? That is this 5, it's not just a 5, it's negative 5. When I distribute the 5 through, I want to distribute the negative also. Okay? And so I get x minus 33 over x plus 3, x minus 3. Okay, guys, so here we go. Boom. Let's take a look. Now, before you start, getting your common denominator, what you want to do actually is factor these things out completely. Okay, so check out on number 3, right? X plus 2, like that's factored. We're good. 3x plus 6, though, I could take a GCF out of there. I can do 3, and then I have x plus 2. Okay, I'm just going to get that out of the way so that I don't have to, worry about that. Okay, now, at this point, anything that matches, like they both have an x plus 2 on the bottom, you don't have to do anything with that, right? You don't have to mess with that. The only thing that I need to do then is I need to put a 3 on this one, because then now the denominators are going to be exactly the same, okay? And this becomes 18 over 3x plus 2. This becomes 6 over 3x plus 2. 18 minus 6 is 12 over 3x plus 2. And then again, if you can reduce those. And so like my final answer is just going to be 4 over x plus 2. Okay? Always look at the denominators, though, to see if there is anything that you can, when you can factor, that you would like repeat. So it's kind of the idea of like up here where, look, they both had a 4, so I don't have to use an extra 4. That would be like going too far. Okay? Okay, check it out. For this first one on number 4, I could factor out a 2 and I have x squared minus 25. But hopefully you guys are noticing these things reasonably quickly. I want you to notice these difference of squares that come up a ton. So x squared minus 25 is actually the same thing as x plus 5, x minus 5. Okay? So let me just use that for my denominator. And then over here, I could take out a 3 and I have x minus 5. Okay? Now, the thing that these two have in common is they both have an x minus 5. So let's start with the numbers real quick, okay? 2 and 3. I do need these to have the same denominator, and the denominator is going to be 6. 2 and 3 both go into 6, okay? So I'm going to go like this. Times 3 on the top and bottom here, and times 2 on the top and bottom here. Now that part's the same, okay? So now the only other thing I'm missing is that this one over here needs an x plus 5. All right. And then basically I've got, okay, 3 times 2, I've got 6. I've got an x plus 5 and an x minus 5 all in my denominator. And then on the top, I have Let's see here. Okay. That will give me 12x. It's plus, so that's good. Now I'm going to take this and distribute it, right? So 4x times x, that's 4x squared. And then 4x times 5, that's 20x. Okay, I can still do a couple more things here. I can combine that and that. So I have 4x squared plus 32x over 6x plus 5x minus 5. I can see if the top factors it all, so I can reduce it. And I actually can take out a 4 and an x. Wait, does 4 go into 32? Yeah. 8 times... oh, I'm not running out of room. I've got all sorts of room. Okay, so it's going to be like 6x plus 5x minus 5. And the last thing is that, yeah, I will go ahead and just reduce my 4 and my 6 to a 2 and a 3. And then, like, so typically I would leave my answers at the end all nice and, like, factored out here, okay? We want to do that because the next step, my friends, which you guys are going to do on Friday, the next step is going to be graphing. And there's like quite a bit of cool stuff I want to teach you about graphing, okay? So when it's all factored out, it's like a lot easier to graph. All righty. Okay, dope. Okay, you guys, we have talked a bit about factoring out something like this. Now, first of all, I can definitely take a 2 out ahead of time. So we talked a bit about that, right? And then, about how you want to check these numbers to see if you could take something out first. Okay, and then when I factor this, whenever it's 6 and 5, it's a little tricky because it's like, do you do 2 and 3 or do you do 5 and 1, right? Well, I have to multiply to make 6 and subtract to make 5. I'm actually going to do 6 and 1, and it's plus 6 minus 1. So it's going to be x plus 6, x minus 1. Okay. Now, you might notice right here, before I even do the rest, I can cancel out that x minus 1. That's going to save me a little bit of time, actually. I'll just leave like a 1 right here. Okay? I can do that. Beware that, especially because we're going to start talking about graphing in a little bit, we talked about this kind of the other day, but when you cancel something out like that, what it does is it produces a hole in the graph at that point. I think I talked to all the classes about that. If not, it's cool. But you just have to remember whether you cancel it out at the beginning or at the end. Remember, like, okay, I crossed something out there. All right, so now at this point, here's what I'm looking at. Okay, I'm looking at a 2x plus 6 and a 3. Well, I need to multiply. 3 and 2 is 6. I need to do a 3 on the top and bottom of this one, a 2 on the top and bottom of that one. So now I'm good with that number. But then I also need to do an x plus 6 on the top and bottom of this one. Okay? So here's what I get. The denominator, 3 times 2, is going to be 6x plus 6. All right. On the top, well, this part's just 3. This is 10, and when I distribute it, 10x plus 10 times 6 is 60. So when I put that all together, 10x plus 63 over 6x plus 6. 10x plus 63 does not factor, so I am good to go. Okay? All right, sweet. Let's check out this last one here. Okay, I'm going to take that, and I'm going to factor them. What multiplies to make 5 and adds to make 6, plus 5 plus 1. And then here, factor out a 3, and I get x plus 1. Now, this and this are the same, so I don't have to repeat those when I'm trying to put this all together, right? But because I have a 3 here, this one needs a 3. And because I have an x plus 5 here, this one needs an x plus 5. By the way, I am not crossing these out. I was just pointing them out, right? So you can see that that's what was on the bottom. Okay, so look, in my denominator, I have 3x plus 5, x plus 1. And on the top, I have 6x squared minus 5x minus 25. Okay? Oh, and notice, you guys, that I did, when I distributed this, I distributed the negative with the 5. Okay? I highly doubt that's going to factor. I mean, I can always check really quickly. Negative 150 and 5. Jeez, let's see. Oh, holy crap, that factors, you guys. I absolutely did not think it was going to. Wow. 15 and 10. Okay. I stand corrected. That's cool. Now, I got to do this thing where I divide them both by 6. You got to reduce both parts. Don't forget about that. So, okay, 15 and 6 both divide by 3. So that's what, like 5 over 2? 10 and 6 both divide by 2. So that's like 5 over 3. Okay, final answer time. Here we go. 2x minus 5. 3x minus 5 over 3 x plus 5 x plus 1. That is dope. All right. Okay. So adding and subtracting, cool. Hopefully it's not too bad. The big thing to remember on this is common denominator first. All right. Beautiful. Okay. So now we're going to move on to solving equations. All right. Solving rational equations. There's something really important that we're going to talk about here, and this is also called extraneous solutions. All right. You guys really want to know this just in terms of like any type of equation you're solving, but it really comes up in 2 places that I can think of, and that's when you're solving rational equations and when you're solving square root equations. Okay. Sometimes you get what's called extraneous solutions, which are solutions that you find, but they're not really solutions. Okay. We'll talk about that in a second. So, all right, what I can do first, okay, so let's look at these problems. Let's look at this first one. I see that I have x minus 6 right there. The first thing I'm going to do is say, like, I'm just going to write it off to the side. I know x cannot equal 6 on this problem. So if I solve it and I get 6, that's what's called an extraneous solution. If I get any other number, I'm chilling. Okay? So here's the other thing. A lot of people will teach it like this. I'm going to show you guys a trick, though, that's better. Is they're going to go like, okay, let's get a common denominator. And so I get 5 over x minus 6 minus 1 times x minus 6 over x minus 6 equals 1 over x minus 6. And then they'll say, oh, look, all your denominators are the same. That's great. So we can just take this and make our equation, okay? So 5 minus 1x minus 6. I have to distribute that 1 real quick, or that negative actually. So it's 5 minus x plus 6 equals 1. Negative x plus 11 is 1. Subtract the 11, that's negative 10. X is 10. Now, I didn't get 6, so I'm chilling, so that's my answer. Okay? But I'm going to show you guys a trick that's going to make this a bit faster, all right? And here is the trick. What you want to do is you want to find what's called the, sometimes called the LCM, the least common multiple. I mean, it's also kind of a common denominator. When I look at this and I say, okay, what do everything on the bottom, like including this one, because this one's like over 1, right? Everything on the bottom, what do they all go into? Well, 6x and x both go into 6x, okay? Instead of making that my denominator, check out what I'm going to do. I'm going to multiply each term by 6x, okay? And then look what happens. Right here, 6x and 6x cancel out. Right here, I just get 6x. Right here, x and x cancel, and I get 6. It's basically, you guys, a way to go from this step to this step without like all this other junk in between. Okay? All right, so check it out. If I solve this, I end up getting 5x, and then I'm going to go plus 6 plus 6 equals 10, and when I divide that over, x equals 2. Now, how do I know if it's an extraneous solution or not if I didn't like check ahead of time? Basically, you just look back here and make sure it doesn't make the bottom 0, which it doesn't right there, and it doesn't right there. So, like, I'm chilling, okay? So whether you check what it's not allowed to equal at the beginning, or if you just check your answer at the end for extraneous solutions, you're like good to go. Okay? All right. Let's check this out. Now, I'm still going to do this, you guys, where I'm finding an LCM, right? Or what everything goes into. Take a look. You still want to factor out anything you can factor out. Like right here, I can take out an x and an x minus 6. I'm left with an x minus 6. So like if you look at all the denominators, okay, a couple of them have an x in it, a couple of them have an x minus 6 in it. So what I'm going to do, all right, my LCM, I'm going to call it x minus 6. All right, and instead of trying to get that as a common denominator, I mean, you can, it's just a couple extra steps, right? What I'm going to do is I'm going to multiply every term, sorry about that, by x minus 6. Okay, check it out. On the first term, the x and the x minus 6 will cancel out. The only thing that's left is a 1. That's exciting. On the second term, the x minus 6 cancels out, so the only thing left is a 1x. And on this last part, the x cancels out. So I have 5x minus 6. I'll just go ahead and distribute that right now and get 5x minus 30. And then to solve this, okay, subtract x from both sides. I get 4x. Add 30 to both sides. I get 31. And so when I divide by 4, x equals 31 over 4. That's like ugly, but okay. Now, the extraneous solutions on here, it would have been if I had gotten 0, because x can't be 0, or if I had gotten 6, because x can't be 6. I got 31 over 4, so I'm chilling. Okay? But, like, the things that make your denominator 0, those are your, what would be extraneous solutions, like if they were solutions, okay? Okay. You guys, you know, it just hits different sometimes. Nice cold Diet Coke. You know, you just feel like you're going to die. All right, check this out. Minus 4x plus 3, and oh my goodness, I wonder what this is going to factor to. It's so crazy, it factors to x minus 4x plus 3. I'm just kidding, that happens like quite a bit, okay? To where I could say, all right, cool, my LCM is x minus 4x plus 3. On a side note, right, that means that in my equation, in my solutions, x cannot be 4 and x cannot be negative 3. So I just need to remember that. Okay, cool. I'm going to multiply this one. Actually, first, hang on, I'm going to move that out of the way. All right. Okay, I'm going to multiply this one by x minus 4x plus 3. Multiply this one by x minus 4x plus 3. And I'm going to multiply this one by x minus 4x plus 3. Okay? Okay, check it out. We're going to do x minus 4's cancel. If I distribute that, I get x plus 3. Here, x minus 3's cancel. If I distribute that, I get 5x minus 20. Here, they both cancel. plus 2. Now we should go about solving this equation. Okay, subtract x to the other side. So 3 equals 4x minus 18. Add 18 to the other side. Uh, 4x equals 21. And then if I divide by 4, I get x equals 21 over 4. It's really hard to make these questions like come out to nice whole numbers, so you will get a lot of fractions. Don't be stressed out if you're getting fractions here. Okay. Okay, cool. Let's look at number 11. Right? If I factor this and I have x plus 3, okay, when I look at all these, so obviously my LCM is going to be x plus 3. Okay. Okay, so right here, I'm going to do x plus 3. Right here, x plus 3. And right here, x plus 3. All right. X plus 3's cancel, so I get 1x. X's cancel, and when I distribute that, I'm going to get 2x plus 6. And everything cancels, and I get negative 3. Okay? Let me go ahead and combine these together. 3x plus 6 equals negative 3. If I subtract that over, 3x equals negative 9, and x equals negative 3. All right, you guys, this is why we check for extraneous solutions. If I come back up here, what is x not allowed to be? Well, it's not allowed to be 0, and it's not allowed to be negative 3. Because look at what happens when I try to plug in, go back to the original problem, okay, like pretend we didn't do any of this stuff right here, go back to the original problem. What happens when I plug in a negative 3 right there? I'm dividing by 0, okay? That is no bueno. So, put all this back. All right, so I got x equals negative 3, which is no good. So this actually has no solution. Okay, doesn't have any because the only solution I got was a extraneous solution. All right, cool. Let's check out this last one here. Here's my LCM. X minus 5, x minus 2, and well, that factors to x minus 5, x minus 2. Okay? So, that is my LCM. Okay, right now, if you want to think about it, at this point, all right, x is not going to be able to be 5, x is not going to be able to be 2. Okay, now let's go ahead and multiply everything by x minus 5, x minus 2. Okay, here, the x minus 5's cancel. When I distribute that, I get x minus 2. The x minus 2's cancel. When I distribute that, I get x squared minus 5x. Here, everything cancels, and I just get 3. Okay, let's combine like terms. I'm going to put that x squared first. I'm going to go ahead and combine the x minus 5x because that's negative 4x minus 2. And you guys, whenever you're solving a quadratic, the first step is always get it equal to 0. So I'm going to go ahead and bring this to the other side. So here's what I'm working with, okay? X squared minus 4x minus 5 is 0. So if I can factor this and solve it, those will be my solutions, okay? All right, I get multiplies to make 5, adds to make negative 4 is negative 5 and negative 1. And so my solutions are x equals 5 and x equals negative 1. Now, if I look back at the beginning, right here, x was not allowed to be 5. It also wasn't allowed to be 2, which it wasn't. But it wasn't allowed to be 5. So I come over here and I say, actually, no. I only have one solution, and that's at x equals negative 1. Okay? So what I would like you guys to do for the rest of the period, we're going to go ahead and work on the homework that goes with this section, okay? Something you might want to do on this front page is just like pay very close attention to the minus ones because you are going to have to distribute those negatives, all right? Make sure you factor these things and like fully simplify them at the end, okay? All right, and then over here, you're going to solve these. Okay, so remember, you look at the bottom and like, what can I multiply by to get rid of? Here, you got to do common denominators. Here, we're solving and seeing what we have to multiply by to get rid of. And just remember to check for extraneous solutions. I'm going to post up the answer key as well so that you can check if you are doing it right. Okay, I don't mind if you guys help each other out and stuff on the homework, but please make sure you're working on the homework. And then at the end of class, do your exit ticket. All right. Hopefully that makes a lot of sense. You'll have one more lesson without me on Friday. If there's anything on here that's confusing, go ahead and just let me know if you have like any homework questions or something, and I can go over it in our next video like I would if we were in if I was in class with you. Okay? Otherwise, guys, hopefully that helps, and hopefully you guys are good to go. Like I said, I will post the answers to this too, so just check them as you're going along. Make sure you're getting everything right. All right. Have a great day, guys.